Good afternoon and welcome to the sixth of our monthly HUD Water Wednesday webinars hosted by EPA's WaterSense program. I'm Laura Wetzel from Eastern Research Group, which is a support contractor for EPA's WaterSense program. And I'll be serving as the MC for today's call. This series was initially developed by HUD and EPA colleagues in the West, who wanted to increase awareness of the tools available through EPA's WaterSense program as HUD-supported properties work to add water efficiency to their existing energy efficiency efforts. We opened the series to a wider national audience to ensure that more could benefit from the information. Today's webinar is on gray water reuse. Is it right for your facility? First, a few housekeeping items. To avoid disruption during the webinar, all attendees are muted. If you have questions or comments during the webinar, please add them to the chat box you see on your screen. We will have time for questions during the webinar, and we'll also respond to any questions we don't get via email following the webinar. We know that people are busy and may not have had time to attend today, so we will be recording the webinar and posting it to the WaterSense website on the URL you see on the slide 2 to 3 weeks after the call. You'll also be able to find recordings of previous webinars and registration links to our future webinars on that webpage. Okay. Before we dive in, we'd like to get a sense of how many of you on today's call are new to this series. So we have a little poll for you. So have we met? Yes, I attended one of the earlier live webinars. Kind of, I watched one of the recorded webinars. Or no, this is my first time. So we'll just wait for another 10 seconds and show everyone the lay of the land. All right, it looks like most of you are first timers, so welcome and welcome back to the third of you that have already attended one of our HUD Water Wednesday webinars. Okay, now let's find out who will be speaking to you today. Today's presenters are Charlotte Ely, Megan Pryor, and Renee Rodriguez. Charlotte Ely is a life scientist with the US EPA. She works for the Sustainable Water Infrastructure Program, providing technical support and financial resources to help communities become more water and energy efficient. She's the WaterSense liaison for the Pacific Southwestern Regional Office, EPA Region 9. Meg Pryor is a project manager and designer at Hyphy Design Laboratory, an interdisciplinary ecological design and engineering firm based in Oakland, California. Meg came to Hyphy in 2014 with a background in civil and environmental engineering and a master's in ecological urban planning and design for sustainable development. Meg has worked on projects around the world, from participatory design to Sweden to rainwater harvesting systems in South Africa and composting toilets in the slums of Uganda. Wow, that's a lot. Meg is passionate about the intersection between sustainability, community, development, and design. And at Hyphy, manages projects that push the boundary of current design practices and revision the built environment in the context of ecological systems. Finally, we'll hear from Renee Rodriguez. Renee is an associate for Abode Communities Architecture, responsible for the implementation of architectural design on all affordable multifamily residential developments with substantial sustainable requirements. He is actively involved from conceptual design through construction administration. Since joining the organization, he has successfully completed over 20 projects, including 18 affordable housing developments, 5 of which have achieved a LEED for Homes Platinum rating. His work and commitment in the field of sustainable affordable housing has helped propel Abode Communities as the premier provider of LEED for Platinum homes in the state of California. I'd now like to turn this presentation over to Charlotte from EPA. Charlotte?
Great, thank you, Laura, and welcome everyone. Although this webinar series is being offered by EPA's WaterSense program, we are very happy that HUD is helping us spread the word about the series. For those of you who have been on previous calls, there will be a refresher of the big picture that we talked about in the first webinar. We have federal sustainability requirements that federal agencies and recipients of federal assistance may have to meet to save energy and water. We know that saving water also helps to save energy, so it is important from a pollution reduction perspective and a cost-saving perspective, since if you reduce hot water use, you'll not only reduce your water and sewer bills, but also your energy bills. We know that the cost of water and sewer services are going to increase. Although water is still pretty cheap, rate increases have continuously outpaced inflation, and rate structures are changing to drive more efficient use of water. So saving water can moderate the impact of rate increases. The U.S. population will continue to grow, and water resources will come under added pressure to meet human energy and agricultural needs. We know that climate change can throw a wrench into the availability of water, whether it be too much or too little. Finally, we know that there are opportunities to use water more efficiently in the multifamily sector. Next slide, please. The story in the news is that it's focusing people's attention on water efficiency these days is the continuing drought in the western part of the country. No surprise here, the drought is still ongoing, as you can see on the map on the left. The darker the color, the more exceptional the drought. Additionally, I'll note that extreme drought is returning to parts of Texas and southeast Florida, and Puerto Rico are also seeing more extreme drought levels. On the right, I've provided a seasonal outlook that forecasts how drought is expected to change between now and the end of December. The dark brown indicates areas where drought is expected to persist and/or intensify. The green area is where drought removal is likely. As you can see, there's a lot more brown than green. For those in the West, talk of an El Niño is raising hopes that rains later this year may alleviate the drought. I would caution all to not let wishful thinking get in the way of staying the course and improving efficiency. It will take a lot of rain to fill our reservoirs and even more to help groundwater resources recover. And as we know, it only would be a matter of time for drought to return, so continuing to improve your resilience to drought will be important. Because this is a webinar hosted by WaterSense, and since some of you may be new here, this is just a quick reminder of what we are. Our program was launched in 2006 to respond to the challenges on the left by developing a program to provide the benefits on the right of this slide. Our label in the center is what you should look for when you are in the market for water-efficient products. To date, we estimate that more than 1 trillion gallons of water have been saved through the shipment of WaterSense labeled models, and consumers have saved $22 billion in water and energy bills through their use. Even though the focus of the program is on labeling and certification, we employ a variety of methods to achieve our goals and to help protect the nation's water supply. In shorthand, our program focuses on these 3 Ps: products, practices, and people. Today we are going to focus our attention on practices related to water reuse. Our previous webinars covered the other Ps in some shape or form. Our first talked about WaterSense labeled products and shared the Quantity Quotes platform that you can use to make bulk purchases. Our second talked about people, how to communicate with them to drive behavioral changes to use water more efficiently. Our third talked about specification to WaterSense homes, single family and multifamily, and other types of products. Our fourth, general best management practices for multifamily housing, and our most recent covered how to track energy and water through EPA's Portfolio Manager. These other webinars are available for viewing via YouTube, so if you miss them, you can still check them out by visiting our page dedicated to this series. Today, we are going to talk about alternative water sources, and more specifically, gray water reuse. Our Water Sense at Work Best Management Practices Guide covers the range of alternative sources and their potential uses, so I advise you to check that out sometime. But today we are going to hear about some on-the-ground example of how water is being used by HUD-related properties in California. And so today's webinar, we're going to feature the gray water initiatives of two affordable housing organizations, including projects Hyphae Design Laboratory is managing for multiple Eden housing properties and Abodes Communities 7-unit LEED Platinum development, Casa Dominguez. But before we wanted to dive into those presentations, I'd like to briefly review some gray water basics. What is it? What are the benefits? Is it legal? And how much does it typically cost? So gray water, what is it? It's gently used water from your bathroom sinks, showers, tubs, and washing machines. It's not water that has come into contact with feces either from the toilet or from washing diapers. Kitchen sinks are the source of a fair amount of water, usually very high in organic matter, food, grease, etc. And kitchen sinks are not allowed under many gray water codes, but are allowed in some states like Washington, Oregon, Arizona, and Montana. Gray water may contain traces of dirt, food, grease, hair, and certain household cleaning products. While it may look dirty, it's actually safe and even beneficial source of irrigation water in a yard. I won't read through this note on gray water quality today. If you like, you can read it through later. As with our previous webinars, the slides will be available on the WaterSense website. So gray water, the benefits. There are many benefits to using gray water instead of potable water for irrigation. It can decrease potable water use by 16 to 40% depending on the site. It can reduce the energy needed, approximately 2 watts per gallon of water, and the chemicals needed to treat wastewater. It can decrease water and wastewater utility bills. It can diversify a community's water portfolio and provide an alternative source of irrigation water, reserving treated potable water for high-quality water needs. Another benefit of using gray water is that it connects us to our water supply, helping us understand where our water comes from and where it goes. Becoming conscious of our water supply encourages healthier product choices and engagement with our landscape. By reusing household gray water, we preserve water resources for other living things. In concert with water-wise landscaping, rainwater harvesting, and conservation, using gray water as a resource helps reduce our dependency on imported water and protects watersheds. But is it legal, you may ask? Gray water regulations differ around the country. Some jurisdictions have performance-based codes, some have prescriptive codes, and as you can see in the map at right, many jurisdictions have no codes at all. Performance-based codes describe health and safety requirements for gray water systems. Systems that meet the requirements are legal, those that don't are not. Performance-based codes are written in simple, straightforward language. States and local jurisdictions can provide further guidance, but specific details are left out of the code. Prescriptive codes specify exactly how to build a gray water system, including what materials and parts can be used. For example, they may estimate gray water production based on the number of bedrooms in a house and then size the irrigation area based on soil type. Gray water advocates prefer performance-based codes. The state of Arizona developed performance-based guidelines to educate residents on how to build simple, safe, and affordable systems. If residents follow these guidelines or best management practices, their systems fall under a general permit and they don't have to apply for an individual one. Similarly, in California, washing machine systems that do not alter a home's plumbing and that follow 12 basic guidelines also don't require permits. A few BMPs identified by Arizona and also in the state of California include things like avoiding human contact with gray water or soil irrigated with gray water, using gray water for household gardening, composting, and lawn, and using it in a way that ensures it doesn't run off your own property, not surface irrigating any plants, etc. Next slide, please. So how much does a gray water system cost? Well, it really depends. The estimates shown in this slide come from a study completed by an organization called Greywater Action. They surveyed 20 greywater professionals about materials, costs, labor, and permitting costs for 259 residential systems. These systems were either laundry to landscape systems, branch drain, or pump systems. The survey showed that the cost of greywater systems greatly varies depending on how simple or complex it is to alter a home's plumbing, how large the yard is, and who is doing the installation. Of course, economies of scale affect cost too. In today's presentations, Megan and Renee will talk about greywater systems built for multi-unit buildings. We'll hear about costs as well as many other considerations. But before we do, we'll first take a quick poll question. And after, we'll briefly hand over the mic to our surprise guest, Krista Egger with Enterprise. Krista Egger is a Senior Program Director of the Green Communities Initiative at Enterprise Community Partners. With 10 years of experience leading energy efficiency initiatives, Krista manages Enterprise's National Green Training and Technical Assistance Programs. She's going to tell us a bit about how Eden Housing is funding their greywater scoping project. And now on to the poll.
Thanks, Charlotte. And I see that many of you are already answering that. So we're just wondering get a sense of where folks may be on the spectrum of including greywater in their facilities. Okay, well, it's great to hear that about 20% of you are already doing greywater, and a lot of you are interested in learning more before you consider it. So thanks for that insight. And now we'll hear from our surprise guest, Krista. Krista?
Great. Thanks, everyone. I'm happy to be here. So I'm Krista Egger with Enterprise Green Communities, which is a division of Enterprise Community Partners. And I'm just going to share just a few minutes about some of these institutional drivers in the affordable housing sector that can make it a little bit simpler and more attractive for affordable housing groups to delve into this greywater reuse area. So a little bit about Enterprise in the beginning. Our founder, Mr. Jim Rouse, created the Enterprise Foundation, now known as Enterprise Community Partners, in 1980 upon his retirement as a prolific real estate developer. And ever since then, we have focused, in short, on increasing both the quantity and the quality of affordable housing around the country. We bring together the people and resources to create affordable housing in strong neighborhoods, and to date have invested nearly $18.6 billion, helped create nearly 340,000 homes, and touched millions of lives in affordable communities across the country. We do this in 3 different ways: through capital, such as giving grants or loans to affordable housing groups to implement these green building practices; through policy at the local, state, and national level; and then through programmatic solutions, which is really what we're talking about today. You can go on to the next slide, where you'll see a logo of one of these programmatic initiatives in which we're heavily involved. The Better Buildings Challenge is based out of DOE at the national level, but it expanded to the affordable housing sector in late 2013. And I just wanted to make sure that everyone on the call was aware of the opportunities here. So the Better Buildings Challenge, or the BBC, is a presidential leadership initiative which calls on multifamily housing owners, managers, and operators. It's a voluntary program, and working with DOE and HUD, Better Buildings Challenge signees make public commitments to action, specifically committing to reducing their energy intensity across their entire portfolio by at least 20% within 10 years. And implement their plans to achieve these savings, improve our environment, and reduce our dependency on foreign oil. So while this is an energy initiative, last year a water pilot was established within the Better Buildings Challenge with similar commitments for portfolio reductions. And Enterprise is serving as a role of technical assistance provider to the Better Buildings Challenge, to groups that sign on and make these commitments. technical assistance to help groups meet their goals is available. And if you go on to the next slide, you'll see a list of different affordable housing providers around the country who have signed on to the Better Buildings Challenge and who are receiving technical assistance. And one example that we'll hear about today is Eden Housing, based in California, which is specifically focused on this water question of how they can reduce their water demand across their portfolio in significant ways during the next 10 years. And so specifically with Eden, we're looking at how they can not just install a few gray water projects in certain properties here and there across their portfolio, but how they can really begin to start institutionalizing the knowledge about identifying opportunities for gray water system implementation. And so HiFi Design Labs with Meg Pryor on the call here has been leading the on-the-ground work with Eden that we've been doing through the Better Buildings Challenge. And so I'll turn it over to her to give an in-depth explanation of how this project has developed over the past several months.
Great. Thanks, Krista. So, yeah, as Krista said, my name is Meg Pryor, and I work with HiFi Design Laboratory, and we've been working closely with Eden Housing over the last few months to analyze feasibility of different water reuse and conservation systems for their properties. So what I'm going to go over today is just a brief technical overview of how we make decisions about feasibility for gray water systems, and dive into some different types of systems that are available and that we've been thinking about. And then give a brief overview on the specific project and lessons learned from that project with Eden Housing. So this slide shows sort of our first analysis when we go to a site is to look at the water balance. So how much water is coming into that site? What is the potential for reusing that water on the site? So the black line in this graph, it shows all the potable water demand. So basically the water that is read off your potable meter. And then the gray bars are showing irrigation water demand, and the orange bars are showing gray water demand. Again, that's showers, sinks, and your laundry room. And then the blue bars here show, hypothetically, if you could collect rainwater from all of your roofs, this is how much water you could collect. So what we can see from this graph, first of all, is that the rainwater and the irrigation, those curves are opposite. So in summer, when your irrigation demand is highest, your rainwater is essentially almost nothing. And this is from a California site, so it's climate specific, obviously. But what we can see is that the gray water demand throughout the entire year is relatively constant. So in summer, your gray water does have a significant potential to provide your irrigation demand. And so when we look at this graph, what we really think about in terms of deciding on design implementation is we want to bring that black line down. And there's two main ways to do that. The first is just to conserve water, so using less water in general, whether that's through water-efficient landscapes or low-flow fixtures. And then second of all, the water that we do use on site, how can we reuse that water more than once to make the most of it? So if you go to the next slide, so again, just an overview of the different systems that are available for gray water. So the supply is coming from hand washing sinks, your laundry rooms, showers, and if applicable, any air conditioning condensate. And then the two main uses for gray water, or reuses for gray water, are landscape irrigation and indoor non-potable use. And for landscape reuse, there's a variety of systems that vary in cost and equipment requirements. And I'm going to go through those in the next slide. So if you go to the next slide, so the most basic system is a direct laundry to landscape, and you're essentially piping directly from your laundry machine outside through the wall outside and into a mulch basin. So basically an area of mulch around a plant, or as shown in this picture, or a long linear strip of mulch with a variety of different planting plants. And to note, because or at least in the state of California, all of these piping happens below the surface to protect from any public interaction with that gray water for public health requirements.
So this is sort of your lowest cost system. And then if you go to the next slide, a slightly upgraded that system would be to connect your laundry machines to some of your other fixtures in the building, and then do a similar non-pumped, what we call a branch drain system. So essentially, just using the flow of gravity to direct that water out to different mulch basins and plants. And the challenge with this system is that it's really dependent on your site grading and if it's feasible to use the gravity of that water flow. So if you can't, then on the next slide, an alternative would just be a pumped system where you would collect all the gray water from your building in a temporary storage basin or a dosing basin, as shown in this picture. And that would have a pump that would pump out to an irrigation chamber or a mulch basin. And the benefit of this is that it gives you more control over how far you can send that water, and also make sure that the water is more evenly distributed to the different plantings. But it comes with higher costs for the tank and the pump and higher maintenance costs for that pump as well. And then an even sort of higher technical system that provides you with more technical control, as well as a more water efficient system that allows you to irrigate more of your plants, is filtering your gray water and then connecting it into a drip system. And this this requires higher costs and usually requires a permit depending on your state. However, there are many companies such as Rewater that provide the package system and has a lot of experience working through these systems with customers to help facilitate that process and keep it as efficient and affordable as possible. And then the other option is to reuse your gray water indoors. And there's some companies, in the lower right-hand picture, you can see some companies have proposed products to do that in a very affordable, direct way. So this literally is taking after you wash your hands, your water from the sink directly into your toilet, using that water for flushing. So there's no treatment and very little transport required. And then the more sort of designed or technical option is to collect all of that water into a tank, filter it, and treat it with ultraviolet light for disinfection, and then pump it back to your toilets. And the benefit of this system is that all of your building gray water will usually exceed your non-potable demand for toilet flushing. You can essentially ensure that you'll supply 100% of that toilet flushing water. The challenge with this system is that it often doesn't make sense for retrofit options because of all the re-plumbing that is required, or the dual plumbing to plumb your gray water lines in addition to your existing water supply and sewage lines. However, it does make a lot of sense for new construction. So on the next slide, I've just provided this, and these are cost estimates that we've come up with the help of contractors for the Eden Housing Project. And so what you can see is that, and these are for retrofits for multifamily units, and I provided the cost here that would be for a typical laundry room with about 4 machines. And what we notice from these is that even though you have significant water savings from anywhere from 8 to 20%, your payback periods are relatively long. And most of the affordable housing companies that we've been working with ask for a return on investment of preferably 5 years, if not 10 years. And again, this is sort of the challenge is that water is relatively cheap, and so even though you have significant water savings, they're not always translated into cost savings. And then I'm not showing the cost for gray water to indoor here, but just to give you a brief or an approximation of what that cost would be. Some direct systems can cost as low as $200. That's just the sink going into the toilet system. Whereas the filtered and treated systems for new construction, you'd have about anywhere between $5,000 and $15,000 for your treatment system, and then to dual plumb all your pipes, it's about a 10% premium on your plumbing cost. But that does have a pretty fast payback between 5 and 10 years. So now what I'm going to give you a brief overview on the next slide of our project that we've been working with on Eden Housing. So just to be brief background, Eden Housing is an affordable housing company located in California, founded in 1968, and has properties mostly in Northern California and a few properties in Southern California. And so Eden Housing, if you go to the next slide, but Eden Housing provided us with a list of approximately 120 properties of theirs. And this map on the right here sort of shows you the breadth of those properties. And then on the next slide.
Sorry, Krista, it's taking a little while because of all the photos to load and like move forward. So I apologize for the delay in that, but hopefully y'all should see the Eden Housing Project with the numbered list now. So just be a little patient. Thank you.
Thank you. Yeah, so Eden Housing provided us with approximately 120 sites to analyze. We did a preliminary site survey with those property managers who provided us with preliminary site characteristics. And then from that information, we chose approximately 30 sites to visit and get a little bit more information about and talk to the property managers, maintenance staff in person. And then we did essentially that water balance analysis that I showed you earlier for each site, looking at what the opportunities were for systems. And then we developed a schematic level design and cost estimate for 11 of those sites. And then on the next slide, just to give you a brief overview of how we made those decisions about which sites made more or less sense. And it was also many of these sites, a system could have worked. It was just we ended up choosing sites that were most feasible or had the highest cost benefits. But what we look at is we look at the existing water balance. So what are the flows of water on the site? Where is the opportunity to save the most water? And for this project with Eden Housing, we were looking at rainwater and gray water. So does gray water make the most sense? Does rainwater make the most sense? And we looked at site conditions. Are there any existing infrastructure that we can take advantage of? Old tanks that aren't being used? Any sort of stormwater basins, overflow retention basins that aren't being used that can be taken advantage of? The building characteristics. Is there space for a tank or a filtration system? Where does that make the most sense? How can we avoid as much pumping as possible, as much piping as possible? And then also I think it's important to mention sort of the people context of this. Many gray water systems require some behavioral changes and education on the part of residents. So it's really important to have the management on your side to make sure that they're excited and committed to implementing this system and taking care of it. And then of course these are affordable housing properties that we're working with, and cost is a major factor, both in terms of reducing upfront costs and reducing long-term maintenance costs. And so this just gives an example of one of the sites that we are working with. This site is actually just outside of Los Angeles. And so we looked at sort of what are the existing conditions on the site, what are the existing characteristics, where is the landscape, where is the laundry room, are there pipes exposed that might allow for some sort of retrofits to the existing plumbing or make it easier, where is there space for tanks. And then we provided several different options for systems to be feasible and came up with cost estimates with the help of contractors and approximate payback and water savings. And the thing that I wanted to point out with this site in particular is what we found. We suggested a laundry to landscape system, which if we just a laundry to landscape system in itself saved about 38% of their irrigation water. But if we combined that with Chirrup's conversion to water efficient landscape, that water savings went up 38% to 61%. So this goes back to the discussion of, first of all, how do we conserve the amount of water that we're demanding by converting to more water efficient landscape and water efficient irrigation systems. And then once we reduce that water as much as possible, how can we incorporate gray water? So then if we go to the next slide, we've been thinking a lot about, sort of towards the end of this project, how can we take the lessons that we've learned and the methodologies that we've used and increase the impact of that. So we're in the process of developing an online tool or dashboard that can essentially automate the process that I just described that we went through, where any of Eden's property managers, and hopefully in the future we'll be able to expand this tool, and any property manager for multifamily residential property will be able to input some basic site characteristics, basic preferences, and this tool will automatically calculate different system options, basic sizing, basic cost estimates. And the goal with this is to provide property supervisors with an overview of their options, so that they can use that with upfront budget planning, and then it will provide them with a report that they can take directly to a contractor and be able to say, here's the system we're interested in. We know it will cost about this amount. Can you sort of do the final design tweaks? And our hope is that this sort of a system would facilitate the implementation of the more widespread implementation of gray water systems and get over the any initial hurdles that exist. So thank you, and I look forward to answering any questions that any of you have.
Thanks a lot, Megan. That was really great to see kind of your thought process and selecting recommendations for your projects, and that online tool sounds really neat as well. So our final speaker is Renee Rodriguez with Abode Communities. Renee?
Yeah, I'm here. Thank you very much. So good morning still. I will be talking about a project that we did a couple of years ago. This is Casa Dominguez. It's an affordable housing project. First, a little bit about our organization. We also were founded in 1968. We started as a volunteer organization of architects trying to provide design services to the low-income community. We grew as also a development firm, and we also have a property management firm. We work as independent divisions, but also sort of share information in the context of new projects and sort of experience of the properties. Abode Communities, as an owner of properties, has 33 buildings in the LA County area and adjacencies. And so as that, we sort of have a good pool of projects to kind of mine and get information for future developments as we design our new projects. A little bit about the project. Casa Dominguez was a former 3.5-acre brownfield site in East Rancho Dominguez, which is a neighborhood unincorporated LA County, and then also had sort of one of the lots on the city of Compton. This project started, sort of design came to our office in 2007, so it kind of aligned with the Lead for Homes, the launch of the Lead for Homes pilot program, so we jumped right in. And gray water, so we really kind of looked at everything we could do to increase the efficiencies of building the system, and sort of committed to sustainability as understanding that reducing the cost of running these properties and really providing high quality housing and healthy housing, it's something that it's more of a social responsibility when we're sort of housing people who don't have a lot of choices. We believe that we should make sure the choices are the best ones. This property not only had typical multifamily units, but also had sort of emancipated youth component, so the people who were coming out of the foster care program. So it had a child care and a health clinic as part of it. Although sort of I'll quickly run through some of the highlights, being one, panelized framing to reduce waste. We had blown insulation to ensure sort of tight seals. We had cool roof to sort of reduce the solar transmittance and the heat loads. We had sort of recycled flooring and resilient flooring. We also had all Energy Star fixtures. We had 84.87 kW system that actually does 100% of the common area loads, and the gray water, which is what we're going to talk about. So gray water, why not? Well, we didn't have it early in the project. We got really lucky on the sort of the market, how it worked for the project. So the owner had a little bit of extra money to do something and to increase the sustainability of the property, because it's something from the mission that we have. And as I showed you, we did a lot of things. So gray water, we didn't have a lot of new things to do with the which are typical. We could, 100% Energy Star, would do blown in, but those things we're already doing them. So the first point, sort of the why gray water, why not? The why not, which is why the second point says value and cost, is it's not cheap to do it. And at the moment that we're doing this back in 2008, or talking about this 2008, there were no incentives. So it was more of an understanding kind of mission alignment that basically by recycling the gray water, we're reducing the impact of sort of, we're using that water twice, right? We're using it for washing, and then we're using it for irrigation. So that means we're sort of reducing the impact on the infrastructure, taking water out of the sewer system. So it seemed like a proper and correct thing to do. And as somebody mentioned, the energy waste in Southern California, we're getting our water from up north, so it takes a lot of energy to actually really do that. And the part that I said value instead of cost is, by using the gray water, there is a cost of running the operation that it's significantly less. But as it was mentioned, irrigation water at that time was not necessarily that expensive. It's going up, but it hasn't gone that much up. So, but it was something, we're using the water, it makes sense to reuse it. In some properties, it could also reduce your sewer fees because you basically are dumping less water in the sewer system. In this project, actually, we had the irrigation individually metered, so actually that presented a challenge on convincing people to do this. And the scale, we had a fairly large central laundry room, which we could take all that water, which was being dumped in the sewer system, and really take advantage of it. So the size of the project, the size of the landscape that we had in the project, it sort of made sense. Not everyone agreed with this. So we had a sort of couple of challenges, the permitting environment being one of the biggest ones. And basically, this was the first multifamily, large-scale multifamily gray water system for LA County. So not everyone was as savvy as we are now about what it takes, what gray water is. I mean, we had a great one of the early panelists had a great description of all of this, which would have made our life really much easier in our process. But we didn't have that. So we really had a little bit of an upscale battle to convince mainly the public health department about how safe gray water is and what we're going to be, and how we're going to use it. We had great partners on LA County that really supported the battle. There were many times when we thought about giving up. But with a lot of tenacity, the whole team, including actually Steve Bilson from Rewater, which was mentioned earlier, Jack Khalifa, which is a mechanical engineer, and our team kind of pushed forward and make sure that we were sort of committing to providing a safe system that everyone was kind of okay with. The other thing is, as I mentioned, because of the marketing environment, this actually happened during construction, which was sort of a huge challenge because we had to redesign mechanical systems, plumbing systems, electrical systems, and landscape kind of as we were going through constructions. And being an affordable housing project, they have extremely tight schedules. We had a contractor who was patient and willing to work with us. Not an easy thing to find, but it was critical for us to really sort of be able to do this because full set of plans have to be generated, new landscape plans, and as I said, plumbing, electrical, and everything on it. One of the sort of the biggest challenges that we had is being in Southern California. There's not a lot of rain, and I know we had less rain the last 4 years or so, but we've never had that much rain. So a good landscape design here, it's drought-tolerant plants. So now we were going to switch to a gray water system in order to make sure that we use as much of that water as we could. We had to switch the plant material from drought-tolerant to one that will absorb the water. Of the whole site, It was focused mainly in the interior courtyard, which I could sort of hear is where the laundry was located. And sort of on the side, adjacent again to that line, in order to ensure that we would use the water that we were producing, so the owner wouldn't be just spending money on a technology that wouldn't actually serve the purpose, and even though it had a 25-year payback, as was mentioned earlier by Megan, we wouldn't want to extend that. One of the problems we had on that had to do with the code requirements for irrigation, which are a little absurd, high on the side of the calculations that need to be provided. But we met all the requirements, and sort of, again, beautiful landscape that was proposed. And the plant palette, one of the tricky things about the system that we had to do that, as was mentioned earlier by Megan, the gray water system is not a water purifying system. So there is sediment, there is a little bit of higher salt content, there are other things. So not only the plant material had to be selected to take in the water, but it had to actually support the quality of the water that was coming. So that's not every plant material. So our landscape architect worked with a chemical lab. So it was kind of a cross between horticulture and chemistry and science to come up with a plant palette that will do both, absorbing the water that was produced by the laundry system, and will survive with it. You know, a quick thing on our system, we did the sand filter system that was mentioned earlier. So basically what a typical sand filter system does, it takes all the water, the gray water, it basically takes it to a tank where it stores it. It goes to a sand filter, which is this guy over here, and the sand filter basically filters out all the sort of the particles, small particles, so lint, some dirt, hair, sort of bigger particles. Again, the water is not being purified. So a drip irrigation system is what's recommended, but it has to be specifically designed for gray water because the particulates can actually clog the system. And then we take all that water and distribute it throughout the courtyard. One of the things that we did in our system is also had a storage tank, because in the situation where the gray water wouldn't be enough to supply the whole area, it will be sort of there will be potable water as well. These are some highlights of the system, and we can sort of look at here the storage tank. One of the things about gray water, different than rainwater, as we guys are looking at new technologies, is the fact that gray water has to be used within 48 hours because it turns septic if it doesn't. So because of that, we had our storage tank, our filtering station, and there's the potable water sort of connection. And as it was mentioned earlier, in California, they don't want contact with gray water, people, dogs, and such. So we have to put these signs all over the place to make sure that no one's messing with it. And this is the pump and controllers, because basically there's a pump and there's a controller from ReWater that is measuring the amount of water that's going into it and making sure that it's providing the potable water if they need to sort of supplement the system in order that we're getting enough water to irrigate the system. And as it was mentioned, the critical thing on this property had to do with resident training. It was really difficult to sort of convince people that the smell of sort of clean did not come from Ajax or Fab, or if everyone sort of knows Clorox. You know, you can see in the slide that it talks about thrifty moms. So the cost of using sort of better clean materials was critical, because these products going into the gray water system would have killed any plant material. So we were really lucky with our partner in the property management as part of the lease-up. This being a lead project, they had to do the tenant training, but they actually worked and got people on board and making sure they understood what the system was and the benefits of the gray water system, and actually sort of train and educate about the availability of other cleaning products that not necessarily are going to be dangerous for the environment and won't kill the plant material in there. They went a step beyond, and as a welcoming present to all the new residents, they provided in their recycled bins for the kitchen green cleaning supplies, one of them being a detergent. So they would then start using it. And not only that, I think they, if I remember correctly, it was about 6 months they donated the clothes washer detergent in order for them to start testing and getting familiar with the quality. And one of the things back in 2009 when the property came online is that green cleaning supplies were not as readily available as they are now. So I think getting the buy-in from the residents was critical for our project. And one of the things is, as we talk about this, and when we started talking about me being part of this panel, the technology has come a long way since 2007, 2009 when we put in service. And but we've had now the project up and running for about 6 years. So one of the things that we can sort of look, we had 2 benchmarking tools in order to monitor the property. So actually, the gray water system is offsetting 85% of total irrigation load of the project, which is a fairly big amount of the irrigation load, not necessarily a big amount of the total potable water demand of the property, because it's 70 units of housing, but it is a significant number, and it's something that is starting to, you know, as we're looking at the mission, it really it makes a big sense that we're not using potable water or as much potable water to irrigate the property. We've only had 2 service calls in the time that we've had this project, and I put 5 here because it has to do with the moment that the laundry machines were in place. So it's 5 to 6 years, 5.5 years or so. And not only is that we're saving money, if you look at the irrigation and you look at the landscape has not suffered by using this system. Actually, we had to, because it was a brown water site, we had to bring 24 inches of good soil to the depth of 24 inches. That plus abundant water, because we have way more than we need on the gray water system that it's producing. You can sort of see beautiful, lush landscapes that are being seen around. And lastly, a couple of points. I guess lesson learned from our side. There's a lot of technological advances. So there are a myriad of gray water systems. The reason I say tread carefully is one of the things on the numbers that have been provided by the previous presenters. Make sure that the gray water system is an appropriate system for the size of your property. Don't spend that much money. The word of payback on gray water system is not necessarily, 25, 12 years, I think is the numbers that we've been talking about. That's not really great. So making a system that is going to produce more water than you need, or is way more expensive or complicated that your maintenance staff would do, will not increase that payback periods. So let's make sure that we're looking at an appropriate application of the system. The regulatory environment has become way more knowledgeable, as the previous presenters talked about, having places where they have prescriptive systems. So that's great for one thing. The other thing is that in reality, there are certain things you cannot do anymore. So let's make sure that whoever you're working with kind of knows what they're doing. Financing and permitting environment, there are some incentives for new technologies like gray water, and you heard Krista talking about sort of how they're supporting this. It's still fairly expensive to do gray water, and there are a lot of challenges, as there are places, even in the state of California, that do not allow gray water systems. This is kind of doing piecemeal, so sort of there's no comprehensive gray water standard as we sort of move forward. The gray water is one of the things that, since we did this project, placed in service in 2009, we've had it in every project, but because of the cost, has been kind of in the chopping block in every project since. Our system, kind of talking about numbers, cost $60,000, kind of on the high end. One thing to remember when you do affordable housing, at least in California, is that affordable housing has restrictions on the wage determination, so that means it's a little bit more expensive. So let's make sure that we tread carefully on what we're doing. But this is kind of the way of the future. As water becomes less available, even here we got the charge from the governor in reducing potable water use by 25%. We're meeting this charge pretty much across the state, so that's good news. But applications through different cities are actually talking about gray water already. They're talking about implementation of gray water. So it's, even though we can talk about payback, this will be the way of the new housing. So we should prepare for it, not necessarily escape from it. And the technology, like I said before, is rarely available. ReWater being one of those companies that are basing their system on off-the-shelf products. Basically, it's a pool filter with a sophisticated controller, not necessarily a very complicated system, because the other thing is systems that your maintenance crew cannot maintain are going to be a burden on the property. So we have to kind of adapt, and I think gray water is one as part of the menu of things to use for reducing potable water use and making sure that water is an available resource. We have to sort of jump in whole hog. And with that, I thank you very much for your attention.
Thank you, Renee. That was a lot of great information. Those future recommendations are really helpful, and you have a lot of really good irrigation numbers that are promising too. So we are getting towards the end of our allotted time, but we can still definitely take some questions that we have gotten in, if you guys don't mind sticking around. And we do have just like a few more final slides before we end the webinar. So on the topic of kitchen water use, can't kitchen water use invite salmonella into the system? And is that why it is sometimes prohibited in gray water regulations?
Anybody can answer.
Yeah, anyone can feel free to jump in if you have any knowledge about kitchen water use in the context of gray water.
Krista, do you want to take that?
This is Meg. I can talk a little bit to our experience first, and then if someone else wants to add in. At least in the state of California, the main concern with kitchen water use that we're aware of from a public health perspective is the high level of organic compounds and sediment in the system. We've had conversations with public health where we, depending on the situation, if it's a kitchen sink that's not heavily used as it would be in a restaurant, but more in an office setting, then it's generally okay to permit for use as a gray water system. It just, I'm not personally aware of any situations where salmonella has been a concern. I think it's more just the high organic compounds, but that's my experience with it.
Okay, good to know. I think, Meg, it might have been you who mentioned an effect on washing machines that gray water can have, like a negative impact. Is it just that it might like reduce the lifetime of a washer, or what type of negative effect does it have on washing machines?
Yeah, so just for the first system that I presented that I called the direct laundry to landscape system, where you're using essentially the pump from the washing machine to pump the water into your landscape, that because it's sort of overusing that pump in a way, it will decrease the life of your washing machine. However, if you want to protect your washing machine, you can do a pump system. So you basically dump all of the water from your laundry machine into a basin that has a pump in it, and then that pump will pump it out to your landscape, and your washing machine will not be affected at all in that system.
And what type of like average lifetime reduction, like a couple years, like reduce it by just a little bit, or?
I'm not sure exactly, but I want to say 3 to 5 years. So
Okay.
it will reduce like maybe 25% of the life, depending on the washing machine.
So I know Renee talked about having to, switch to special laundry soap. So it's definitely, has an effect on the landscape effect use. And Miriam is wondering, just because it's difficult to monitor this laundry soap use at housing authority owned property. So any suggestions on that would be helpful.
Well, one of the things that the property management tried to do, which just got really complicated, is actually vending machines and the laundry. because the ease of use. One of the things that has happened is when we did this property, green cleaning supplies were basically at Whole Foods. I don't know if I can mention other, like vendors and stuff, but I think we know now that everywhere there's green cleaning supplies. So availability of green cleaning supplies have come down significantly. I mean, it has gone up significantly. The price, because there's more places that have it, has gone down. I think Costco has their own brand. Smart & Final, I'm sure, has something. So I don't think that the idea. The idea of green cleaning supplies being a problem. The main issue is powder detergent. Even liquid detergent is not that much of a problem. But one of the things our client did was to actually start them up. So they gave him basically a couple of months supply of cleaning supplies so they could use it
If they could just speak.
and get accustomed to it. And once you get accustomed, then there's no reason to go back.
Okay. Thanks, Renee. Yeah, it's good to know about the powder versus liquid issue. And we are having some curiosity about how the cost of water plays into your kind of gray water decisions and calculations of savings. Can you speak at all to cost of water at properties and how that impacts decisions?
Yeah.
Megan, you want to go first?
Yeah, I can just go into how sort of technically how that played into our calculations. I mean, the cost of water is pretty much that's where your savings come from, based on the current water rates for different water utilities, and that in the state of California at least, it's generally assumed that there's between a 5% and a 9% increase in average increase in annual utility rates, which is pretty significant. And then when we look at payback and long-term costs, we're looking at basically the savings from a reduced water rate minus any increased maintenance costs. And Renee, I don't know if you have any.
Yeah, no, I agree, and I think gray water as a technology is sort of, as you saw the chart that Megan had, the direct, basically putting a pipe to your soil seems to be fairly cheap, but anything else is significant. Our system was $60,000 because of prevailing wage. There is a book out there called Water Wise Home by Laura Allen that puts our system tied between $25,000 to $30,000. I guess that doesn't account for prevailing wage, but you sort of, in California, we have a drought. So the real option has to do with sort of, and irrigation seems like a no-brainer. I do think irrigation is where you get less benefit. I think, as Megan had mentioned, if we are able to get into flushing your toilets and to get the non-potable use inside the unit, then you get a better payback. Because irrigation, what you use for irrigation, as I said, drought-tolerant material basically takes care of it. We don't irrigate that much. So if you take the price of water inching up significantly, that's not going to make the payback. 12 to 25 years for most properties, that's the time that you're reinvesting anyway. So it's not going to make it. You have to kind of do it because of the mission, but if you were able to get inside the house, and then you're talking about flushing toilets, and that's a larger number, and then you do irrigation and other things. I think gray water should be part of the menu of the technologies available. I think Megan was talking about the fact that they got 61% reduction with the change in the plant material plus the gray water. So I think part of a sort of menu of technologies used to reduce the potable water demand, then you can realize those larger savings. But irrigation, sort of a laundry system to irrigation, you have to do it kind of because of the mission. The payback length of 12 to 25 years, I think, makes it challenging. I think if there were some rebates encouraging new technologies that will bring the cost of putting the systems in place down, that would be great. I think it's great what Enterprise is doing, incentivizing this, and I think that might be the kick that the systems need in order to become more affordable and then reduce that payback period.
Great. That's some really helpful numbers and context for your savings. So that's all of our questions for today. So we just have a looking forward. We have one more final scheduled webinar at the moment. For all of our webinars, we hope to have guest speakers from HUD properties or examples of successful efforts around the country. So if you have a story to share for our October 28th webinar, or if you think we should do more future webinars and have a story to share, please do let us know. You can email us at watersense@epa.gov. And although this is our final schedule webinar, we are open to holding additional ones. So if there's a subject we haven't covered on a webinar and you'd like to hear more about it, please, you can type that into your chat box right now and we'll review your input to inform future activities, or you can also always feel free to email us your suggestions. And a reminder that HUD has set up a Water Watch forum on their Switchboard platform, and the link is provided here. We encourage you to check it out and provide your feedback. So that's all we have for you today. So you can visit us online and learn more about WaterSense and the future HUD webinars and those URLs shown on the screen. And you can feel free to email the WaterSense helpline at watersense@epa.gov with any questions. So thank you again for joining us. Thank you to all of our wonderful guest speakers, and enjoy the rest of your day.
Thank you.
Thanks.